see if I have questions here. I think the chat seems to have been blowing up during my talk here, but I don't know what's there. So.
Yeah, there's a lot of stuff going on, but thank you first for the talk. It was really nice. And we have at least one question in the chat for you. I might have missed some because, as you mentioned, there's like a lot of questions. Will, you had one. You want to ask it yourself?
Oh, hey Troy. Kind of obvious question for me to ask, really, but I'm interested in kind of your view on it. Can you imagine a time when the performance infrastructure in LLVM, especially the sort of high-level performance infrastructure, perhaps vPlan, and or the Fortran front end, they're different questions really, but as something to highlight, the MLIR presents a really interesting technology for the Fortran front end and maybe the C front end in the future. Can you imagine a time when those are sufficiently mature and useful that HP Cray could imagine switching to those in order to make use of them while still maintaining your competitive advantage of the specific things that you do with those tools as a downstream commercial compiler, but use those technologies?
So MLIR is very new, and vPlan, as you mentioned, that was something that we saw discussion about that. It sort of peaked a while ago, and we haven't really heard much more about it. So there's a lot of things there that could contribute to having a better optimization framework upstream. But so you're asking, can I envision that ever happening? Well, I can imagine it happening, but it seems like it would be several years down the road. All of those projects, I think, would have to improve more before we could do that. And like one of the things with I think you mentioned, or at least in chat, I think you mentioned the Fortran front end, and one of the big issues there is how you handle array syntax, and we've been really curious to see how that's going to be handled with FLANG, especially if they're using MLIR, how that gets represented, because we've had experience for a number of years where if you lower the array syntax to loops too early, you actually lose a lot of information that's useful, and you kind of it's very easy to have it end up throwing a lot more code at your compiler than it really needs to maybe look at all at once. It's very easy in Fortran to write an array syntax statement that expands to a very large loop nest. And so I think a lot of those problems would have to be solved before we could go that route. And likewise for the vectorizer in LLVM, it's definitely not as capable as our vectorizer in our proprietary optimizer. And we've been taking a look at that and trying to see, can we extend it? Do we need to maybe write our own from scratch inside LLVM? What do we need to do there? But we haven't seen a lot of progress on that recently. Upstream, I mean.
Okay. Just to come back for that, if you don't mind.
Sure.
I think that talks to a difficulty that open source software has in general, and LLVM in particular, which is if kind of the value of open source is when you get more out of it than you put in, and it's perfectly reasonable from a business perspective for anybody who has a more capable tool chain to kind of hold back from wholeheartedly jumping into LLVM for all of what they do, and I guess For the rest of us, then trying to make sure that LLVM becomes as capable as possible so that it attracts as many people as possible. The same definitely holds for the new Fortran front end. Is a challenge.
I feel like that was more of a comment than a question, so I'm not sure I need to respond to that.
There was no question there. That was my own view.
Okay.
It's fine. Yi, you had a question.
Yeah, my question is regarding OpenMP runtime libraries, because just like the C++ is evolving and new features added, OpenMP specs is also evolving and have way more complexity compared to the past, like OMPT, OMPD, then the offload portion, all these features being added and needs to be implemented. And I clearly, as a customer, I'm not happy with the runtime library, especially regarding the offload. So I was wondering if Cray would consider enabling using the LLVM side libOM and libOMP target as an option, at least, compared to your proprietary OpenMP libraries.
I'm actually going to have to pass on your question because so as a point of clarification, I manage the CPU optimization team, and there's a completely different team within the company that handles OpenMP and would be able to respond to your question. I can certainly pass along that feedback, but I'm just not able to respond to it.
But there might be like some open source stuff that is actually usable by people, which is good. That's what I take from the question. There was another one from Itra.
So I'm like kind of very curious about, very interesting talk about the journey from going from a mature compiler architecture and adopting LLVM, which is also our experience, right? We're trying to do the same kind of thing and moving to use, to adopt more of LLVM within our compiler infrastructure. And I noticed when you were talking about your architecture slides, that progressively have moved starting from the low level backend, LLC, start to use that, and then start to replace the front end, like you say, because of keeping up with the language changes in C++. And now you're using the high-level optimizer with augmentation for C++ and C code generation. But if I'm correct, and I understand your slide, you're still defaulting to use your own high-level optimizer for Fortran.
Yes.
And I'm kind of curious to know what is your experience? Have you guys tried to use opt and found that it's not sufficiently mature to handle Fortran constructs? I guess you already explained a little bit that some of these array syntax become loop nest, and so does that point to more work that needs to be done into the high-level optimizer to handle more complex loop nest to make it easy for vendors to use for Fortran?
Well, the problem is kind of twofold there. So on the initial side of things, you have to be able to hook up Fortran to LLVM, and we be in a similar situation to the original CLANG. So the original effort, which was hooking up the old PGI front end to LLVM, and the difficulties that they had in connecting kind of a much older code base to a much newer code base, and dealing with all those sorts of issues. So we'd have to get past that first. But then even if we did hook it up to LLVM, what we've seen is that the LLVM vectorizer is just really inferior to our proprietary vectorizer. And the loop transformations also just aren't there. Now, it turns out on the C and C++ side, that's not as important. The LLVM optimizer is better at scalar optimization than our older competitor optimizer is. You know, we focused for many years on Cray vector systems, and scalar is kind of an afterthought in that world. But when you're compiling C and C++, scalar optimization becomes a lot more important, because it's not as typical that you end up with a Fortran style loop in the middle of C++ code where it has all of the nice properties that Fortran has. Now, maybe if you've restricted all your pointers and you've been very careful and all that, then you end up with a vectorizable loop that is easy enough for the LLVM vectorizer to catch. But you know, for the most part, I think for Fortran, you need a stronger vectorizer in LLVM in order to get performance out of it.
Yes, that kind of chimes toward our experience, that particular loop optimization. And I hope that with F18, then having an open source Fortran front-end will end up exercising and stressing more the loop optimization infrastructure in LLVM to make it better.
Okay, so I was about to ask what you think is the most important feature we upstream has to improve on, but you already answered that. And thank you very much for your talk. Thank you all for your questions.